Welcome to Data 8, everyone. Thank you for joining us today. All right, so the semester is underway. What I wanted to do today is introduce myself and my co-teacher and share with you what we're going to be doing in this course this semester. Hi, I'm Dave Wagner. I'm so excited to be here with all of you this semester. I'm really looking forward and hoping to see some of you in office hours. I come from computer science. I love this course. One of the areas that I study in computer security and recently privacy and machine learning. And I am super fortunate to be joined by my co-instructor, Professor Ani Adhikari, who is a superstar for this course. She is one of the original creators of Data 8 and a brilliant teacher and statistician. And Ani, would you like to say hello to everyone and introduce yourself?
Sure, thank you, David. Likewise, I am thrilled to be teaching with David Wagner, who's too modest to say that he too is one of the developers of this course. We started on this journey, about 6 years ago now. And for 6 years, we have wanted to teach together. Finally, we can do this. And finally, we're back teaching the thing that the course that we really love. I came to statistics from physics via mathematics via probability theory. And, it's all about making decisions based on evidence. And the events of the world are telling us how important it is to be able to do that. So I've made my life trying to basically, work with people to develop that skill. And so that is the thing that I love to do, and that's why I love to be in Data 8.
Great. Okay, so let me also tell you, oops, this is just not my day, is it? Let me also tell you about the course staff who are joining us. You have a great team of super qualified and knowledgeable course staff who are here and would love to help you with your learning. You can look on our course webpage to learn about our teaching assistants and our tutors who are going to be one of your main primary points of contact with this course. So data science, this is a data science course. Let me tell you a little bit about what you're going to learn in this course and what data science is. Lots of ways to think about data science. One way to think about it is that we're learning about the world using data. And in this course, we have a specific focus on analyzing and understanding data using computation to help us. So 3 major themes you're going to see in this course. First theme you're going to see is data exploration. When you've got a new data set, you've got a bunch of data that got handed to you, maybe the first step is to try to understand what you got. And so often during an exploration phase, we're going to look to see, are there any patterns that we might spot, any trends, any interesting themes that seem to come out of the data. Visualizations are our friend here. So we're going to teach you in this portion of the course how to work with data, how to look for these trends, how to make visualizations to help you understand what's in the data.
Yes, are you taking notes?
Hi, thanks. We'll be recording this lecture and we will post the recording afterwards. If you have questions, I would love to see your questions. Please feel free to post your questions in the chat. We have people who are monitoring and would be glad to answer questions you've got. The second third of this course, we'll be looking at an area called inference. I see some of you are saying there are folks who can't get in. Unfortunately, due to mishap with Zoom this morning, this room has capacity for only 1,000. So if you know any friends who can't get into this Zoom room, go to the post on Ed and you should find a link there to YouTube. And we're also streaming live on YouTube, and those folks can join us on YouTube. We should be fixed. Hopefully this should be a one-time occurrence, and we should be able to fix this before lecture on Friday. I'm so sorry about this. Unfortunately, everything seemed to be working when I tested it, but unfortunately I didn't have a way to test with 500 people showing up. So this is one of the joys of the first lecture. All right, so the second theme in this course we'll teach you about is inference. And inference is about using data to draw reliable conclusions about the world. So in exploration, we might identify some potential patterns or some trends. And inference, now we can go test whether those patterns are something that we can count on, something that we can rely on. And so this portion is going to use a lot of a technique from statistics. So we'll teach you a bunch of statistics in this course. And then finally, the third theme in this course is prediction. In the last third of this course, we'll teach you how to make predictions about the future. In other words, make informed guesses about what might happen in the future or things that you haven't observed based on data that you do have. And there are a bunch of techniques out there. One of them you'll learn about, you may have heard of machine learning, which is revolutionizing a bunch of technology areas, and we'll give you a teeny bit of introduction to machine learning. Okay, so that's the structure of this course. The purpose of this course is to give you a first introduction to data science so you get some of the major themes. It's not enough to have a career as a data scientist, but it'll get you started. One of the things that's unique about this course is designed to be accessible. So you don't need a huge amount of math background. So for instance, how many of you have never had any statistics course before this? Yes, lots of people. All right, if you've never had statistics course, this course is for you. This course was designed for you. You don't need any stats background. How many of you have never had any computer science or computer programming course? If you've never had any computer science or any computer programming, this course is also for you. This course is designed to be for everyone. So if you get lost, or if I start talking about something you don't understand, I want you to interrupt me and help me out, because our goal here is to make this course something that for everyone, and we're going to try to teach you everything you need. We're going to teach you everything you need to know about computation. We're going to spare you from heavy math. We're going to teach you everything you need to know about statistics so you can do data analysis. Let me pause at this moment and say that I love seeing questions in the chat or reactions or feedback. So please don't feel bad about sharing comments in the chat as we go. All right, so that's this course. We're also accompanied by connector courses. I don't know how many of you know about this, but we offer connectors. These are separate courses that let you see some of the applications of data science. So in this course, we're going to teach you the core concept and core techniques. But applications are a really critical part of data science. And if you want to be a good data scientist, you can't just look at the techniques in isolation. It's really valuable to apply them to the real world. And so our connectors give you a chance to apply these ideas to a bunch of different domains. So they might be a really fun way to see these methods in action. There are also often smaller courses where you can learn about a new topic area. You can find a list of connector courses online. Let me just highlight 4 of them that currently have seats available if you might be interested in taking a connector course designed to be taken together with Data 8, could be taken after Data 8, but ideally you would take them together. You could use you could look into political science. You could look into Physics 88 using data science for physics. You could look at Data 88E, and you could look at EPS, Earth and Planetary Science 88, which is titled Pi Earth. It's using data science to study the Earth around us. All right, any questions about the course or course content? Not all the connector courses are available every semester. Every semester, some of them are available, maybe some new ones. Will you need to install Python or specific software? Nope, you're going to do everything through your web browser. I'm going to show you what it looks like. You can find the links in this slides by going to our course webpage, and you'll find there a link to today's slides. And if you look in today's slides, you can get to all the links there in the slides. Connector courses are usually a smaller number of units. I don't remember exactly off the top of my head. What's the difference between data science and statistics? Definitely there's a strong relationship. We're going to be using a lot of techniques from statistics. Data science is focused at analyzing data. So we're also going to spend a fair amount of time on computational methods that will help us with data analysis. And we're going to care a lot about applications and case studies. But definitely data science and statistics are very closely related fields. I'll show you how to access the software you need. You can decide about when the reading is useful to you. The textbook was written by the course instructor, so it's designed to accompany these lectures. We follow a very similar content and style. So if you're someone who likes to see the book before the movie, you could read the textbook beforehand. If you're someone who likes to watch lecture, you could watch lecture and see if it all makes sense. And then if there's some parts that don't make sense, then you could go back and do the reading afterwards. Figure out what style works for you. Everyone may have a different style. Yes, you'll be learning the basics of Python. It's a programming language that will help you program the computer and enable us to do a bunch of powerful data analysis, even on very large data sets. Readings are not required. You decide whether they're useful to you. This course definitely has an element that's a combination of stats and programming. All right, lots more courses. I'm going to let our GSIs answer more questions in the chat. I'm going to move on. So let me talk to you about the structure of Data 8 and what are the major courses you're going to be doing in this course. There'll be lecture. We're going to offer a lecture live and also recorded. I think it's better for you to attend live, but you figure out what works for you. There's a textbook, as I mentioned, that is free, totally free. Hooray. There is a weekly lab section. Labs start this week. That means today or Thursday or Friday. So go to your lab this week. You'll go to lab every week. Lab will give you practice. It'll give you hands-on application of ideas that you see in lecture. You should be, if you're enrolled, you should be assigned a lab section. You can also get credit without attending lab if you do the lab remotely on your own computer before and turn it in before Wednesday, 9 a.m. So in future weeks, that is also an option if you don't want to attend lab. I personally highly encourage attending lab. I think it's a great chance to meet other students and get help from course staff in person. But if you don't want to attend or you can't attend in person, you can do the lab on your own. As long as you do it on your own, you submit it before 9 a.m. on Wednesday. So for instance, next week's lab, you'd have to submit before next Wednesday, not after the lab, but before the lab. And you have to pass 100% of all the autograder tests to get credit that way. We'll have weekly homework assignments. We'll have 3 projects where you'll get to work on larger case studies. When you go to lab, you'll learn how to submit the lab, and then you'll learn how to do it, and then you could do that from home if you wanted. We'll have office hours for you. We'd be delighted if you have questions for you to come to us in office hours. We have a huge window of time when we're available for questions in office hours. There's a midterm. Please put the midterm on your calendar. The midterm will be, sorry, it's Friday night, October 15th at 7:00 p.m. The midterm will be online. There'll be a final exam as well. Make sure you attend that. You can find more details in our course policies webpage. So if you have questions, I recommend looking there first. All right, let me talk a little bit about collaboration. The purpose of this course is to help you to learn, and we encourage you to help each other. So you're very welcome to ask questions. You can ask course staff questions. You can ask each other for help. You're welcome to discuss concepts or the problems you're working on with each other. Well, not exams, obviously. You can't discuss that with anyone else in the course. In lab, when you're working in lab, you're welcome to talk with others and work together with a lab. In fact, we encourage working in pairs in lab, but you'll have to submit your lab assignment individually. You'll have to submit your homework assignment individually. You're welcome to discuss the problems with others, but please don't discuss your solutions. Projects you'll do either individually or with a partner. So collaboration is great. Help each other out, but with some limits. You should never share your solution with anyone else except your project partner. So I don't want you to post your solution on a forum and ask what was wrong with my code or my solution, or is my solution right, in a place where everyone can see. Or if someone else asks you, how do you solve this problem? I don't want you to show them, well, here's what I came up with. Obviously, don't copy off each other. Any kind of copying or a violation of the academic conduct policies could result in severe penalties for you. So don't do it. I know that it can be really tempting when we're all online and it seems like no one's watching. Please be scrupulous about avoiding that. If you need help, we are here. We would love to help you. There are multiple ways you can get help. One way is to ask a friend of yours in the course. That's great. I'd love to see people help each other. Helping each other out is a great way. It's not only a great way for you to learn from someone else, but helping someone else is also a great way for you to learn. I found that one of the best ways to solidify my understanding of something is to try to explain it to someone else. You can also ask on, sorry, not Piazza, Ed. You can ask on Ed, our discussion forum, and we'd be glad to help you, or maybe another student will help you. Or you could come to office hours. That's great too. We love seeing you in office hours. Please don't feel scared. We don't bite. We're delighted to see you there and we want to help. You are also welcome to sign up for a tutoring section. Tutoring sections are optional. They're a great resource if you feel like you would like more practice or more help, or if you're struggling or just want to spend more time with the material so you get more solid. We offer optional small group tutoring sections. These will be, each section will have 4 to 5 of you, be 1 hour a week, be a chance to practice, and we'll have a member of course staff there to guide you and help you during this. We'll have post signups in a few weeks. We're not ready to begin tutoring yet. We do ask that if you sign up for tutoring that you commit to attend everyone, because we have limited spaces available for tutoring. If you're stuck, try to solve it and then come ask someone for help. You could tell them what your current understanding is and what piece you're struggling with. Don't sit and spin your wheels for 3 hours with no clue what to do or where to go. If you're sitting in lab and your code isn't working right, you don't have to sit there for half an hour desperately struggling to figure out how to make it work. You can ask for help. It's okay. We all need help. We all went through this. Every one of us went through this process. Part of what we're trying to do to get you to learn is to give you tasks that are difficult. They're just beyond the level of what you already know how to do. So there are going to be times when you're not going to know what to do, and that's okay. I mentioned about collaboration. We'd love for you to help each other learn. The purpose of this course is for you to learn. Support each other. Establish a positive community. You're going to spend a lot of time with each other in this course, and we want you to be kind and be respectful to each other, and help each other succeed in this course. This is not a zero-sum game. We can all succeed together. Please be respectful to our course staff. They're here to help you learn, and they really want to do that. You can find a link to the course policies page on our website. So what I want to do now is I want to shift to showing you an example of some of the kind of data analysis we might do and the software environment we're going to be working with. Before I do that, let me pause and just see if there are any questions that people would like to have answered.
Can you kind of go over what the homework is for the class?
Homework, we'll have a weekly homework you'll do on your own. It's practice with the ideas and the concepts. We'll give you some problems. We'll post them each week.
And they're posted Friday, correct?
I believe
Yeah, I believe so.
Friday and due on Thursday.
Thursday.
Oh,
Yeah.
okay. All right. Thank you so much.
The textbook you can find at inferentialthinking.org. Here, I'll show you what it looks like. Whoops.
Professor, are
What?
the tutoring
That's not
sessions
right.
going to be in person?
I had that wrong. Inferentialthinking.com. If you go to inferentialthinking.com, there's the textbook. You can see what this looks like, and you can read through, and there's chapters, and the chapters correspond to what we're lecturing on. The tutoring sections, yes, will be in person. You will find a link to the homework online on the course webpage. Everything you need will be on the course webpage or announced on ED. So on the course webpage, when we release the homework, you'll find a link. If you attend labs in person, you don't need to pass 100% of the autograder tests, but you do need to be there. You need to be working diligently on it, and you'll need to get checked off. And your lab instructor will talk you through what to do when you get to lab. All right, time for a demo. I want to show you the software we're going to be using. All right, can you see this? Great. All right, so what we're going to be using is the Python programming language and Jupyter notebooks. And if you don't know what that is, that's okay. Everything you're going to need to do programming wise, you're going to do through your web browser. So you're going to open a web page and it'll look something like this. This is called a notebook, a Jupyter notebook. And a notebook allows you to type in computer code and run it and see what the results are. So what we have here in a notebook has a bunch of, we call them cells. Each one of these blocks with a rectangle here is a cell, and you can type something in. You can type some code in, and then you can ask the computer to execute that code, to run that code, and you can see what the result of that code is. Up at the top, you have some menu bars that let you do stuff with this notebook. This is all running on our computers in the cloud, not on your machine. So you get to use all the computational power of our servers. Every one of you are going to have your own copy of each of these things. So you don't have to worry about screwing up someone else's copy. You don't have to install any software. All you need is a web browser. So each cell can have some code in it written in this Python programming language. And then you can run a cell. So this first cell has a whole bunch of stuff, and I don't want you to even try to understand what any of that is. That's some boilerplate that sets up the computing environment we're going to use in this course. Then you can select a cell and click the run button up here, and that will run the code. That will tell the computer, please execute that code. So let me show you an example of using a cell. We can type something into a cell, and we can use, one thing we can use Python for is it's a very simple calculator. So here I'm going to type in 2 + 7, and then I'm going to click run. And that runs the Python code, and the computer figures out the answer is 9, and it shows me the answer is 9. So what I typed was here, and what the computer gave me was there. And of course, I can do more complicated things. And it shows me the answer. Okay. Now, there's a little bit of a keyboard shortcut that's kind of handy, so you don't have to type and then press this run button. I can press Control Enter, and that will run the cell for me. Yeah, Shift Return is very nice. Yeah, you can do Shift Return, Shift Enter. Okay, so what I want to do now is I want to show you a demonstration of the power of what we can do using computing. One of the things that we've done to make this course more accessible is, instead of teaching all the statistics using fancy math and calculus, you don't need to know any calculus for this course. We're going to use some computer programs to do the work for us, which means first we need to teach you how to write computer code, how to write computer programs. So for this demo, I've written you some computer code. You don't need to understand this. You don't need to follow this. Don't worry if none of this computer code makes sense to you. It shouldn't make sense to you. This is just an example of the kinds of things we could do with this environment once you know how to write some computer code. What I've done here is I have written in advance some code here that downloads a copy of Huckleberry Finn and loads it into the computer, and then splits it apart by chapter. And I'm going to show you what we get. Here is the result. This is the text of Huckleberry Finn, downloaded from the web, and then you can see here it begins. You don't know about me without you have read a book, so on and so forth. Okay, so that's now in the computer, and that's now data in the computer, and so we can now analyze it. So I've split this up into chapters. So we can, in this class, we're going to organize a lot of our data as tables. So let's do that. Here I have put this into a table. This is what a table looks like. It has a bunch of rows and a bunch of columns, and here I have one row per chapter. Another thing I could do is I could count. This is kind of a silly thing to do, but we're going to do it. Count the number of times the word Tom appears in each chapter. Don't worry about what this code I'm typing does. I'm not expecting you to know it. What this has given me is it's given me a bunch of numbers, one number per chapter. For instance, in chapter 1, the computer figured out that Tom appears 6 times. And in chapter 2, Tom appears 24 times, and so on and so forth. This is what computers are great at. If you have a really tedious job, like scan through the entire book and count how many times the word Tom appears, computers are wonderful at that. They spare us from the tedium. All right, so what could you see from this data here, these numbers? What does this tell me about Tom? Anything? He shows up mostly in the end. Yeah. It doesn't appear kind of maybe in the first few chapters, and then there's a long period where Tom really isn't mentioned much. He doesn't seem to be a big part of the book. And then in the last dozen chapters or something like that, then he's really important. Another character is Jim. So we could do the same thing for Jim. And here's the answer for Jim. I see, oh, Jim shows up more kind of throughout the book. All right, so we could do this for Tom and Jim and Huck, and these numbers are kind of a little unwieldy. So remember I said we're going to use tables. Let's put that in a table. I've written in advance some code that will do that. And here we get a table that looks like this. So we have one row per chapter, and we have one column per person in the book. And this is maybe just a little bit more organized way to have the data. You could think of this as kind of like a spreadsheet, but it's now in this computer environment where we can manipulate it using our computer code. Now, having all these numbers in a table maybe is a little hard to follow, because how do I make sense of a gazillion numbers there? So when you got a whole bunch of data, too much data to really make a lot of sense of, use, that's right, visualization. So the next thing we're going to do is we're going to visualize. And I wrote in advance some code to now take that table and then compute a cumulative count. For chapter 1, what's the total number of times Tom appeared in chapter 1? For chapter 2, how many times did he appear in the first 2 chapters, and so on. And then visualize that, plot that. So we get a graph that looks something like this. Okay, so maybe this is a little bit easier way to make sense of the numbers. And now one thing we can see very clearly is that Jim is mentioned a lot in the book. Jim is really important and important throughout the book. You can see that Tom, the yellow line for Tom, is pretty flat for a large part of the book, indicating that he's mostly not present. And then near the end, it rises very rapidly, indicating that he's mentioned a lot. And finally, Huck. The book is called Huckleberry Finn, but Huck doesn't seem to appear very much anywhere in the book. Why is that? Any ideas? First person. Yes, it's written in first person. So Huck is the author, and he's writing from his point of view. So of course his name, the word Huck, doesn't appear very often, even though Huck is very important in the story. By the way, you don't have to just watch me do this. You can follow along in your own web page, in your own web browser, and play around with these notebooks. So let me show you how to do that. Every lecture, if you go to the course web page, you will see here a link. Do you see this link that says demos? If you click on that link, demos, what that will do is that will, oh, I'm not signed in, but that will log you into our servers and will load up this notebook, make your own personal copy of the notebook, and load it up and let you play around with the notebook. And you can make changes and run cells and modify something and run it again and see what that affects. And it won't hurt anyone else because you've got your own private copy. Okay, so you could follow along during lecture in your own copy if you want, and even try stuff. Yeah, you'll be doing your labs and your assignments in Jupyter Notebooks. So doing it by opening up a notebook, editing it, changing stuff there, and then submitting it, and we'll show you how to submit it. This code was particularly simplistic. I only counted the number of times Huck appeared. Now that said, if the Huckleberry appeared, actually that starts with Huck, so that would get counted too, but that was just kind of a fortunate coincidence. So this is kind of naive code, and there are more sophisticated ways to work with textual data, but I'm just trying to do something simple here that gets us close enough. Yes, you're all logging in and you are killing our servers. I love it. That means we need to go work on increasing the capacity. If you get an error message, you might have to wait 10 minutes and try again. This is the stress test. We have some of the world's developers of Jupyter Notebook here. And one of the reasons why they volunteer to help us maintain our course website is because I think we have the largest Jupyter server in the world, at least the last I heard, with all of the Data 8 students all trying to access it at once. So this is a stress test on their software, and it helps us improve the Jupyter software. All right, so I want to do the same thing. But now I want to talk about, instead of Huckleberry Finn, I want to talk about another wonderful book, Little Women. I don't know if you've read it, but it's a lot of fun. And Little Women, for those of you who have read Little Women, you know that it's a coming of age story. It's a coming of age story about 4 sisters. The book starts with them as young children, and they grow up and they build an adult life, and you see the progression of them. And the 4 sisters are, let's see, Amy, Beth, Jo, and Meg. Meg. Yes. And it starts off like this: Christmas won't be Christmas without presents. And what's going on here is they're super, super poor. They can't afford any gifts for each other. And the book starts at an early Christmas where they're super poor. Okay. So, beloved book, let's do the same thing. Let's count how many times each of these people, their names are mentioned in Little Women, and do a count by chapter, and do the same thing, visualize that data and see what we can tell. And I'm going to do this for the 4 sisters, Amy, Beth, Jo, and Meg, and also for Lori, who's the boy next door. And that creates a table. And then we're going to count this, have cumulative counts. And I'm going to visualize it. And here we can see some things from this visualization. For instance, here you can see what's the line that's growing the fastest. Well, that's the blue line. That's Jo. Jo is mentioned a lot in this book. If there was someone who is going to be the primary character, maybe it's Jo. Jo is wonderful. You can also see, what else can you see? Yeah, you can see other stuff, like Meg doesn't get mentioned much near the end. And let's try another one. You can see Lori there. Lori is the green line. Spoiler alert, Lori ends up marrying one of the 4 sisters. I want you to take a moment, look through this, and see if you can figure out from this data, who does Lori marry? Amy, yes. Someone want to type in the chat? How did you know? Yeah, their lines are the similar kind of wiggly shape to their lines. When Lori's line goes up, so does Amy's. And when Lori's line is flat, so is Amy's. And what does that mean? In chapters where Lori is getting mentioned a bunch, Amy's getting mentioned a bunch. And in chapters where Lori's not getting mentioned, Amy's not getting mentioned. Over here, you see how these lines kind of are parallel? And that kind of makes sense. What that indicates is they're a couple and they get mentioned together. When one is mentioned, they're both mentioned. And other chapters, when one of them is not mentioned, but neither of them are mentioned. So you can see sometimes from this data, interesting trends and patterns that lets you learn something about the entire book. In this case, we didn't have to read the book, and we learned a little bit of interesting stuff here. Okay, let's do a little bit more with this data. We could look at, instead of how many times the different people are mentioned, we could do a different experiment. One thing that's interesting is to look at elements of a writer's style. And I'm going to do a very simple measure of that, which is I am going to, instead of counting the number of times Tom appears, I'm going to count the number. Well, basically what I'm going to do is I'm going to estimate the average length of the sentences in the book. And the way I'm going to do that is I'm going to count the number of periods. Each period indicates the end of a sentence for the most part. And so if I look at the length of a chapter, the number of letters in that chapter divided by the number of periods in that chapter, that will give me the average sentence length, the average length of a sentence in that chapter. Now, this would be super tedious, as we're getting mentioned in chat, super tedious to compute by hand. You could be sitting there making tallying marks all day. super tedious, anytime you find yourself doing something super tedious, that's when get a computer to do it for us. Okay, so I got the computer to do it for us. It already did it. And let's look at some of these numbers. Here is a table showing for Huckleberry Finn, 1 row per chapter. The first column shows the number of letters, the length of that chapter, and the second shows the number of periods. So you see, if we divide the first number by the second number, we get the average length of sentences in that chapter. And we could get the same thing for Little Women. Now, that's still a lot of numbers and a lot of data, and it's really hard to make sense of. So what should we do when we've got too much data? Well, a good place to start is with a visualization. So let's look at a visualization. And here we have a visualization of the data. And let's see if you can see this. Maybe I make this plot a little smaller. It will all fit in here. We have here in the blue, we have Huckleberry Finn, and we have in yellow, we have Little Women. And one thing you might notice is that there's a diagonal line here. These fall roughly along a diagonal line, and that's because there is for each author a roughly typical average sentence length, and that's about the same for all the chapters. So it kind of makes sense that they would be roughly along a diagonal line. The slope of that line indicates the length of the average sentence. And you could imagine that might tell us something about the author. For instance, books that have a very short sentence length, maybe those are action books, really, short, punchy sentences. Joe shot the gun. He jumped over the fence. He ran away. And really long ones might be more abstract, setting a scene. Okay, the second thing you can see here, this is kind of interesting, is the average sentence length is the same for these two books. And in fact, if we look at text, we find that across many authors, there is a commonality among many people that we tend to write sentences of roughly the similar length on average. All right, so this is an example of the kind of data analysis you could do. We will be teaching you in this course how to do this kind of data analysis. So what I'm going to do now is I'd like to wrap up. Last remarks. We are out of time. Thank you so much for coming today and for putting up with our Zoom difficulties. Lab starts this week, so we'll see you in lab. Do go to lab. Lab attendance is mandatory. If you're enrolled, you should have received an email with your lab time. Go to your assigned lab time this week. Have a great time in lab, and I will see you in lecture on Friday. Thank you all.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.
Hope